In this next module, we're going to be discussing work and energy. And in this first video, I just want to make a couple of quick clarifications about work so that you don't make an assumption that isn't correct. When we talk about work in physics, we're specifically talking about the fact that a force has to be applied and an object actually has to move. Now, in our everyday lives, we talk about being tired as a result of our work, or we may talk about studying as being hard work. And while those things are certainly true, when we talk about it from a physics perspective, we're talking about a very specific situation where we have applied a force and an object has moved. So if I stand here and push against this wall as hard as I can possibly push until I am dripping with sweat and I am exhausted and tired and I just collapse on the floor with exhaustion, if I didn't move the wall, which of course I'm not going to be able to, if I didn't move that wall, I didn't do any work from a physics perspective. So we want to make sure that whenever you think of work, you're thinking about it from a physics perspective and not from the way we normally talk about work just in our everyday lives. Energy is classified as just the ability to do work. Now, you don't actually have to do the work to have the energy. Energy just means the ability to do the work. And so, again, that's something that we can think about as with a correlation in our everyday lives. There are some days we may just go, oh my gosh, I just don't have any energy today, which means you really don't want to get up and do anything. You don't want to do any work. And it's not completely different in the world of physics either. If there's no energy available, then no work can be done. So the everyday definition of energy is a little bit more applicable to our physics definition than our everyday definition of work is to our physics definition. Now, the equation for work is that you have to apply a force through a displacement or a distance. And the way that it's written in the book is you see that it's the force parallel to the direction of the displacement. And the reason that that is so is that that's the only component of the force that's actually going to cause the object to move. We've talked an awful lot about components of forces or components of velocities, and so this isn't any different. If you're going to shove something horizontally, then it's only the horizontal component of the force that's going to go into moving that object. Now, you actually know this already anyway. If you have a great big huge heavy box sitting on the floor and you're trying to move it, you don't stand up and bend over and try to push that box because it doesn't work very well. You are actually going to, if the box is actually too heavy to lift, you probably are going to squat down and you're going to bend your knees. You're going to get your body as low as possible so that the force you apply is as much horizontal in the same direction as the box is going to move as you possibly can by lowering your body and getting yourself down to the same level as the box. So again, that's something that you're already familiar with. You do it naturally because you know that the more force that you put in the direction of the object you want to move, the more effective that you're pushing on that box is actually going to be. So let's talk just a little bit about the units of work. Force, we know, is in units of newtons. And the standard unit that we use for displacement is a meter. And so the units of work are Newton meters, and that is classified as a joule, named after the physicist who did a lot of work in this area. If I break this down a little bit further, we know that a Newton is the same as a kilogram meter per second squared. And so if I take that and I multiply times a meter, I'm going to have a kilogram meter squared per second squared, and that's the same thing as a joule. So you want to make sure that you realize that a joule is the same thing as a kilogram meter squared per second squared, because when we get into our next sections on potential and kinetic energy, you're going to need to understand that aspect so that you can see how all your units are going to be canceling in your calculations.